myself. My name is Vaclav. I work as a support engineer over here at SimpleHW. This is the first webinar I'll be hosting. It's going to be a very short one, so let's not get distracted. And the topic of the Legionella is of the webinar is monitoring and Legionella and prevention of battery growth using IoT. So let me actually go to the first slide just to see what this webinar will be about. I will introduce basically the solution, what we'll be covering, and how we'll cover it. And I will introduce our device for monitoring Legionella and generally all kinds of other use cases. Because we have a new device, and for the Legionella use case, it was adjusted a little, but you will see. So let me take first. Let me just go through what Legionella is. Legionella actually is a group of infectious bacteria. There's around 60 types of the bacteria in there, and it is a parasitic bacteria that can attack humans. And what it does is that it causes the so-called Legionnaires disease. And one of the major when you say of this disease is acute lung pneumonia. Actually, it's a deadly disease, but the risk group is only older people, 50 plus, or people who have other underlying diseases. The disease itself does not spread with a human-to-human transition, so it is not a COVID-like plague. Rather than that, it is a deadly disease that can be contracted through the air, but only around the places where the bacteria grows. Now, the environment where the bacteria grows is water. There are several conditions for the water that need to be met in order for the bacteria to grow. The water has to be stale, and there has to be a certain temperature. If I remember correctly, there also has to be some kind of an amoeba that grows synergically with the bacteria, but that's a question for a biologist, not for us. So if you want further information about the bacteria, I suggest you look it up on Wikipedia, just like I did. When it comes to the environments, so still waters, the bacteria usually grows in older water systems, let's say water filtering systems, water distribution systems, all the buildings, and so forth. When it comes to the growth, the bacteria grows very fast. It multiplies every 4 hours, which means that if the conditions of the ideal growth of the bacteria are met for days, there will be a lot of bacteria, let's say it like that. And generally, when you contract the disease, as I said, it's not a disease that is transmitted from human to human, but you have to inhale aerosol with the bacteria, which means that you have to be close to the source of the growth of the bacteria. Now that this means that generally the most common sources of outbreaks are cooling towers, leaking pipes, older pipes, and so forth. Now, one interesting thing is that the device is called, the bacteria is called Legionella because it was first, let's say, discovered, or it is researched since 1976. Where a group of American veterans from the American Legion had a convention, and out of around 230 participants of this convention, around 30 have died as a result of contracting this disease. And that's why it's called the Legionnaire's disease. And it's actually very recently discovered, if you think about it, 1976. It's less than 50 years ago. It's quite interesting. Okay, so just a quick point. The Legionnaire's disease is not the only manifestation of the bacterial infection. You can also contract a kind of a flu-like disease that's not as serious as this as the Legionnaire's disease. Now, when it comes to prevention of the bacteria, there's one thing you can do, and that is making sure that your water systems are outside of the ideal range of temperature for bacteria growth. And that is what we are doing, basically. There are other ways to get rid of the bacteria. For example, you can have a chemical solution that you throw into the water and it mixes and it kills the cells. Excuse me. But when it comes to the prevention itself, without any interaction with the water, what you can do, and it is simply the easiest thing you can do, and that is making sure that the temperature where you are does not meet the ideal criteria for the bacteria to grow. So the ideal temperature for the bacteria is 20 to 45 degrees. And below 20 degrees, the bacteria goes into, let's say, a hibernation state. And above 45 degrees, the temperature slowly kills the bacteria. And of course, the higher the temperature, the faster you will get rid of the cells. I think around 70 degrees is where the bacteria really is killed instantly. Now, what this means is that if you want to use IoT to prevent this, and actually, if you think about it, it is indeed a massive use case, because you have got institutions, public or private, such as schools, old folks' homes, even hospitals, nurseries, institutions like this, that really need to make sure that their pipes are without the bacteria, because they have a lot of high-risk people or inhabitants around them. So now, generally what you would do with IoT, and what we are doing with our devices, is that we are monitoring the temperature of water, and we are doing it through monitoring the pipes that the water flows within. So let me get to that. Our Legionella prevention device is based on the Simple industry. If you are following us, you know that we have launched the new devices a few months ago, and we will have the final deliveries of the device in about 6 weeks. They will be available commercially. So let me just show you quickly on camera. This is the device. This is just a prototype. I will show you the finalized case later as well. And as you can see, there are two NTC probes that go out of the device. Let me show you now the connector. This is the connector. You wrap it around the pipe like this. And this plastic bit right here is the actual sensor that measures the temperature. Now, since it's an NTC, it really notices the temperature change very quickly. Rather than if the sensor was enclosed in the device, like it is in the SimplePack, for example. So the external sensors, they really do help a lot when it comes to monitoring the temperature efficiently. What that means that it is stuck on the pipes. There is of course some slight delay in the report, as the temperature measured has to first go through the metal pipes and then onto the sensor. But metal generally is very conductive when it comes to temperature, so it's not really much of a problem. And also, in order for the bacteria to grow or like go out of the hibernation state and multiply, and it needs to be exposed to the ideal temperatures for a longer time. The cellular split happens 4 hours, if I remember correctly. So generally the delay in reports is well below what is on the verge of not being usable. Okay, so I've shown you the prototype. Now this is the final case. As you can see, it is a bit flatter and a bit wider than the original prototype, and the mounting flaps are a bit different and more robust as well. The final device will be IP67 or even 68 compliant, which means that it will be completely waterproof. And of course, since the case will be enclosed, in order to monitor the temperature efficiently, you need to use the two external sensors. The device will use the standard API 6 that is used in the SimplePack and the SimpleLeak. And the API 6 already has the connection to the two external NTCs already inside of it, which means that the only thing we're waiting for at the moment is having the final cases delivered, and that's it, because we're waiting for the mold to be finished. If you want to try it out, maybe you were inspired by this webinar and you will want to try out the device for yourself. It's of course possible to get a prototype right now, and of course just keep in mind that the final devices will be ready in about a month and a half. That's it. So for monitoring Legionella, we have actually working with closely working with a client that already is monitoring Legionella, but wants to do it with our devices. So we're putting together the mode, and it is indeed a specific mode just for monitoring Legionella. In the next slide, I will show you how it works, and it's standard in the API 6, so it will be available. And of course, documentation, all of that is available for the mode as well. Let me just quickly mention one interesting thing that is new. Then that is that the batteries inside the device, they will be replaceable. So not only that they have more than 3 times the capacity of the batteries in the SimplePack, you can also replace them when it comes to the end of the lifetime of the batteries. And when it comes to mounting, I've already shown you that the cases have these mounting flaps that you can use to screw the device onto a wall or wherever you need it. But of course, it's also possible to deliver the devices with double-sided tape that can be either removable or non-removable. And it is, of course, a solution as well. Depends on what your preference would be. Now, let me move on to some photos. So you can actually see I've shown you the device on camera, but you can clearly see it in the photos. So I think it's better like this. You can see that the two sensors are labeled hot and cold. I will get to that because that's how the mode is implemented. So I'll explain how it works. And generally, you can use the two sensors to monitor either one pipe or two pipes at the same time. We'll get to that. There's a lot of possibilities you can come up with if you're creative. This is the final case. Compared to the prototype, it's a little lower, a little wider, and more robust, and also the flap is different from the holder in the device before it. So now quickly about the mode itself. It works in a way that it sends you regular uplink messages, and in these messages they contain data from both the sensors. The mode itself is built around what we call a flow, and let me explain this. It's a bit complicated, but when you get the grip of it, it ceases being, so it really is not that hard afterwards. So a flow Or let me come back to the two sensors labeled hot and cold. If you have the two NTCs, you can define either of them to be hot and cold, or of course you can have both. You can have two hot sensors or two cold sensors. Depends on how you want to set them up. And these two sensors basically tell the device how to define a flow. And if the sensor is a hot sensor, the flow is defined by a temperature increase by X. It's a temperature delta, so a change of temperature of, let's say, 2 degrees and more will trigger a flow. 2 degrees is the default delta. And if the sensor is a cold sensor, the flow is defined by temperature decrease by X degrees. Of course, the default is again 2 degrees. Of course, everything is parametrable. All of these can be changed. You don't necessarily need to use 2 degrees. It can be 5 degrees. It can be half a degree, given that the precision of the NTC sensors is very good, and the precision and resolution is up to the half a degree. Of course, you can work with it like that. And so now that the flow is triggered when the temperature is increased, the device switches to a different measuring mode of temperature. Basically the interval is lessened from minutes to seconds or tens of seconds. And when the flow ends, when the temperature goes under the delta threshold, again, the device will record and store this temperature inside. And basically what the payload looks like, we haven't included an example in here because we think that would be too complicated, but generally what you receive with the regular messages is, first of all, you need two sets of data because you have two sensors. So for each of the sensor, you will receive the number of flows, basically the number of temperature exceptions that happened during the monitored interval. I think that the default is 6 hours, so the device sends 4 messages a day, which is well enough for the device to last for tens of years, maybe years. Definitely tens of years is possible as well, considering that the batteries are replaceable. You can use it almost infinitely. Now, in the payload, you will receive per each sensor number of flows and also 4 temperature values per sensor. 2 of those will be maximum temperatures and 2 of those will be minimum temperatures. The maximum temperatures will be outside flow and during flow, and the minimal as well. So you will receive a total of 12 bytes of data. The first byte will be the mode, the second byte will be the event, and then will be 4 and 4. Oh, I'm sorry, 5 and 5 data from each sensor, bytes of data from each sensor. So generally, this you can of course combine the mode with regular temperature reporting behavior of API6 that already is implemented. For example, you can combine it with standard temperature thresholds, which means that you can have both the regular uplink messages from the Legionella mode that can be used to monitor the pipes long term, and actually that you can have data from on a regular basis that you can then store and make statistics with, or work with it like that. And you can have non-regular threshold breach alerts that will alert you when the device is reaches. For example, you could have threshold set up by a little higher than the temperature deltas. Okay, now considering that the mode is a bit complicated, I suppose that there will be some questions about it. So I think it's time to jump to these questions. I think I've said everything I wanted to say. And yeah, Let's go. Please write me your questions if you have any. We don't have any questions. Okay then. If we don't have any questions, okay. Aldo is typing, so let's wait for Aldo. Yeah, how do you fix this? That's a good question. The internal part of the device is has the device actually has three parts. Let me see if I can find the board around here. I have it here. So the device has three parts, and as you can see, show you on the camera. As you can see, the bottom part has screws, so you can simply unscrew the device, and when it is screwed back on, it is IP67 compliant. Is this enough, Aldo? Is it okay? Manfred, yes. It doesn't matter if the pipe is plastic or metal, because generally what you want to do is that you want to put the device away from any metal surfaces. But the NTC cables, they can be long. I think the ones that we use in here are about 1.2 meters. So if you want to monitor metal pipes, of course you can use the NTCs, but the device and the signal from the antenna will not be interfered with, because it will be further from the metal pipe. So the material of the pipes doesn't really matter. Uh, yes. We have generally this webinar is about Legionella monitoring itself, but if you want to use other sensors, the probe types you are writing about, or other ones, it is indeed possible to have them with the device and use them with the device. Generally, if it's not going to be offered as a out-of-the-box device, you can contact us at any time, and we can solve it on a project basis. There would be some MOQ for that, but the boards and the firmware are ready for other sensors as well, not only the NTCs. For example, we are working with a float sensor that is like a reed switch on a cable. It's like this. You have a reed switch in here, and it clicks and it sends a message. So of course it can be connected to the device as well. We have dedicated pins for that, so it's of course possible to connect almost anything. Is this enough, Naim? Did I? Yeah. Okay. All right. Generally, the cables should not be too long, because the longer they are, the less reliable they will be. But if you have a use case where the device would be in deep indoor and you wouldn't be able to get the signal from it on base stations around you, you can of course use a micro base station or a signal repeater or something like that. Generally, this is different basically deployment from deployment of a single device. So I can't really tell you a final answer, but the guys that we are doing this with, they are, in some places they are using a repeater, in some places they are using a micro base station, and in some places they are not using anything at all, because the base station around them the coverage is good enough for them to catch it. But generally, the longer NTC cables, I wouldn't really recommend those. That would not be a solution. I think what you want to do in this case, if the use case would be in deep indoor, is that you want to do something with how the signal is received and not with how long the cables are. Okay, Aldo is typing. For the rest of us, if there's nothing else you want to ask, yeah, okay. I understand that the micro base station might be a pricier solution, but sometimes we don't necessarily need to use a micro base station. A repeater is much cheaper. The micro base station is around 500 euros, if I'm not mistaken, and the repeaters can be in the range of tens of euros. So it is really not that expensive, considering you would have the device, several devices in one place, and then you would use the repeater. It really shouldn't be a problem. So we can, Aldo, we can continue this conversation further. To tell the truth, I am not an expert in the possibilities of lengthening and prolonging the signal. So we can get in touch later and solve. If you would have any deployments where you wouldn't be sure what the best solution would be, I can consult with people who know much more about this than I do, and we can solve it like that. Manfred, when it comes to the pricing, all prices are available on the website, and I think that when the device will be launched, finally, the price will not exceed 50 euros for the Legionella one, including the sensors. But the simple industry in the highest version is less than 40 euros, so I don't think the Legionella will be more than 50. All right. Okay, so I don't think we have any more questions, or do we? Okay, we don't. So thank you very much for coming. This was my first webinar, so it was quite an interesting experience. I'm glad that you have been here with me, and you can always contact us through any channels you deem necessary. And we're looking forward to seeing you on the other webinars. Okay, guys. You're most welcome. Thanks for taking the time to do this, and have a great one. Goodbye. Bye bye.